kind of want this shot of Max diving backwards, and then the camera follows him, and he gets in the water, and so we can see it underwater as well. Okay, so we have to do this synchronized. Okay, 1.
I'm gonna say what I'm doing first.
Okay, go.
Well, why do truckers fall backwards, or why do divers fall backwards into the ocean? Because if they fell forward, they would hit the boat. Haha. So cut that out. That's what we're doing. I am diving into the ocean to find eelgrass and trace the edge. And Owen will film me here.
Yeah. You grab this as it's. Alright.
Ready, set, and action. So we're going to latitude 42.247,123, longitude negative 70.780309. We're going to investigate some eelgrass and do a test on whether our new technology, being Canway pingers, etc., is functionally working for measuring eelgrass, pinging it, etc.
So let us turn on the Canway pingers and we'll see at least whether they will make a proper track. And I would like to see if we can do them in order.
These are Canway pingers. They, whilst we turn them on, they communicate with satellites to record our location, as it were. You turn them on here, and you can engage in making individual points by which correspond to, in our case, eelgrass, and every moment we are over eelgrass by pinging it here.
The other thing that's funny about GPS things is GPSs don't do so well in the fog, believe it or not. So this is basically what low tide in Cohasset Channel looks like, and this is a minus 0.2 low tide today at 6:19, and oh, it is 6:21. Let's get the GoPro ready on the quadrat, and we can pass it in to.
Take the time.
Okay, 7:52. Looks like a good place to toss in.
6:52, I'm sorry.
Oh.
6:52.
6:52. And this is going in. But it is the 3rd of August, 2021. It is 3:01, and that is good. It is a bit of a low tide, and we are going to site 12 or site 16. I mean, site 16 from 2020. And we're trying to see if wasting disease has wiped out this colony, or if it has even just there has been more wasting disease. So have fun out there.
Okay, so can you tell me what your name is and spell it out, please?
I am Maxwell Alexander Fernald, MaxWellEalexanderFernald.
And how long have you been at CSCR?
I've been doing it on and off for a while. I think, let's see, 5 years. I had my first expedition 5 years ago, and I've mainly committed myself last year and this year.
And how did you get started with it?
It's a family business. My brother Carl started doing it, and I thought that was interesting, so I joined.
What's your favorite part of CSCR?
There's also
Involved under purveyor. These are diving flippers.
Yeah, so they're pretty darn angled. Mine's angled where it counts. Mine's also angled where it counts.
All right, so we're going out today on June 12th, 2022 as our first expedition just to introduce people to our eelgrass beds.
And I can mark that we are starting now. You wet? Yeah, it's above our head then. Currently. It's above your head. Yeah, it's above your head.
Likely to me, yeah. If there's something like that that looks like a rock. I mean, Riley, did you see that brown rock at like 11 o'clock?
We should be near eelgrass presence. Alright, we could go, this should be a shorter point, we could go where we try to track the
If we can't find any eelgrass out here today, it's going to be a very different summer than what we had expected.
Any evidence of eelgrass there?
I think, yeah. So, should we head more port, do you think?
Those big puffy clumps of seaweed that look like rocks, we've never seen those before.
Alright. Farewell, Finn. I believe in you, Max.
We just went back out in a my rowing boat, basically to where we used to have a penguins. We went exactly where we tracked the tide line last year, and we found nothing. We went all over the glades and we found no presence of eelgrass, except for maybe one plant. But we're unsure if that was even eelgrass. It could have been spore stale because at that point it was pretty deep. But for where we were tracking the tide line, we were shallow and the visibility was perfect, meaning that the eelgrass there was either moved or was completely dead and gone.
What is the danger of eelgrass disappearing?
So, as I said before, it's really important for the environment. So if it's disappearing, obviously a lot of animals are going to lose their habitat, and it's just not, it's kind of like cutting down trees when you think about it, because they have the same kind of impact with like absorbing CO2 and greenhouse gases. So if those beds are dying, then it's not helping the planet.
What do you think are some of the most important benefits of eelgrass?
My most important benefit is that it's beautiful. This is unfortunately something that most people don't get to see, because a lot of people who encounter eelgrass are boaters who are frustrated that it's clogging their propellers, or divers who don't want to get involved in it because it's messy, or swimmers who think it's icky. And most people who live on land don't get to see eelgrass very much unless it's washed up on the beach, then there are amphipods hopping around in it, and it might be kind of smelly. But eelgrass meadows are just gorgeous habitats, and they're full of life. That's one of the most important benefits to me that I think is not as well known. The other ones are, of course, it provides incredibly important habitat for juvenile fish and invertebrates, especially bay scallops. It stabilizes sediments, it improves water quality. It's gorgeous.
What research could you use for your research, especially from CSCR? Like, what research could we gather for you?
One of the things I'm really curious about, and this is from conversation with other CSCR students and with Susan Bryant, is about how eelgrass moves in time, in particular from one year to the next. So we have some meadows, for instance, there's a meadow in Nahant that's very stable. It's almost always about the same size and in the same place, and the same kind of relatively similar densities of leaves from one year to the next. But there are other meadows where there's a lot of variability. You can go out one year and it's really dense, and you go out the next year and it's really patchy. The students at CSCR are there all summer, and you guys are out on the water and have access to that year after year. I think that's something that would be incredibly valuable for your group to focus on. How is the eelgrass moving just on a year-to-year time scale? Could it be just completely gone the next year? We have seen some evidence of that in some other areas, and there's at least one very shallow meadow that I know of on the North Shore that was a big, robustly healthy meadow, and the next year it was gone and there was nothing but bare sand. And the best explanation I've heard anyone be able to come up with is, well, a flock of brant must have come through and eaten it all. But that was 10 years ago now, and that patch is growing back and it's starting to look healthy again. So the annual scale, like years to decade scale of change in eelgrass meadows, is a really important question that I think would be an ideal one for a group like CSCR to look at.
Eelgrass crucially prevents coastal erosion and ocean acidification, as well as filtering the polluted runoff that runs into the harbor after a large storm. Like most plants, eelgrass consumes carbon dioxide. They engage in a process of carbon sequestration, where instead of converting carbon into oxygen, they store the carbon dioxide underground, locking it away and preventing further atmospheric deterioration. One estimate guesses that eelgrass sequesters between 57 and 139 grams of carbon per square meter of eelgrass each day. Eelgrass beds face global ongoing threats, despite their crucial importance to coastal ecosystems. Human activity like dredging, polluted runoff, and the effects of urban development can be detrimental to eelgrass beds. The beds are put at a risk from invasive species such as green crabs, tunicates, and expansive algal blooms. However, these effects are local and don't amount to the damage that may arise from rising water temperatures and changing ocean conditions. As of right now, it seems that climate change may shape up to be the biggest threat to seagrasses.
I actually got the idea for the grant during my history class last year when I was bored and thinking of what can I do to improve the eelgrass research we do, and I was thinking of how could we automate research. I thought, what if we studied wasting disease and we grew it after I saw an article in my eelgrass research about the first the first instance of seagrass wasting disease in Korea, and it looked surprisingly feasible to grow it. And I started thinking of how I could plan out a tank experiment with Finnimini, and I started thinking about that, and I wrote the grant, and with Susan Bryant's help, we refined it a lot, and we emailed it to Marjot Foundation, and we got the grant. They liked our plan. They gave us $2,500 to spend on resources. We're primarily using these to build up the tanks, to have a good ecosystem where we know that the data we are taking is solid. This includes lights, tanks themselves, robotics equipment for taking data, and a bunch of other stuff that we need to grow the seagrass wasting disease.
That's good.
Okay. Guess I can move a little closer. Okay. So first of all, can you tell us your name and how to spell it?
Yeah, sure. My name is Isaiah Murray, Isaiahmurray.
Okay, and what's your role here?
I work with helping Max on his eelgrass project. I have been doing a lot of the engineering and kind of developing all our sensor and motor arrays. It's basically just our framework for hosting all our inputs and outputs. So the autonomous managing of the tanks.
Okay, and why?
So we want to do this so that instead of having people just monitor the tanks 24/7, we're able to just turn them on and leave them on for weeks and maybe even months, and kind of just let the experiment go by itself, because we found that there weren't many kind of options about autonomously growing eelgrass and testing kind of the different salinity levels. We're trying to monitor the interactions between eelgrass and wasting disease and how wasting disease infected eelgrass can affect the climate around it.
And if you wouldn't mind starting by telling me your name and how to spell it.
I'm Eamon Maxwell, E-A-M-O-N. I'm a student researcher at CSCR, and I've been working on the tanks to grow eelgrass and doing expeditions. I'm most interested in just the growing of the eelgrass because it's very challenging, and it's also interesting and unique, and I've never really done anything like it before.
All right, so we're going to start off with your name. So
I'm Theo Gurtz.
Can you tell me a little bit about eelgrass? Like what you do?
The eelgrass group is trying to figure out why so much of the eelgrass is dying this year and years past. We think it could be because of wasting disease, and the wasting disease could be affected by the salinity in the water, meaning it might grow better in higher salinity water. So we're using tank experiments to work on the salinity.
Can you explain what you're doing and what you're testing, like what the experiment is?
So to grow eelgrass in tanks, which we are doing, we have to cool off the temperature to about 65 degrees Fahrenheit. So the way we did it was taking a hose and pumping out all the water through a refrigerator or a freezer to cool off the water, circulating it back into the tank to hopefully get at 65 degrees Fahrenheit. We have the experiment running in 4 tanks. They all have different amounts of salt in them, which is salinity. Seagrass wasting disease is probably our biggest theory on why this eelgrass has been disappearing. Which salinity experiences the most spread of seagrass wasting disease? So we're going to take a already infected segment of a different plant and paperclip that to the plant in the tank to spread it. And the goal is to see which salinity makes the wasting disease spread the most.
What do you know about seagrass wasting disease, if anything?
The disease became very prevalent in the 1930s and wiped out quite a lot of eelgrass meadows on both sides of the North Atlantic Ocean. And there was debate for decades. In fact, I think there may still be some discussion or argument about what causes it, although most of the researchers that I have spoken to are in agreement that it's this pathogen, Labyrinthula zoster-zosteracea. And it seems to flare up in some meadows and not flare up in other meadows. I don't think I've ever seen a meadow where I haven't seen a single blade that isn't infected.
going out with professional eelgrass researchers Jill Carr and Juliet Simpson, as well as Sarah Grady's intern, to look for eelgrasses in new methods such as drones. That's right, that guy is still there. Also, the other Mr. Drones is gone.
No McDowell, because no McDowell's like scared.
So, how do you feel about the two areas I circled on that?
I can take you there. I have the dinghy attached so we can run that ashore if we need to get into shallower water.
Oh, and the eelgrass is all gone from what we see.
It's either dead, moved, or something happened to it, because we have found next to nothing in terms of eelgrass population.
Here?
Yeah.
Yes.
Yeah, where it was really lush.
Just this year.
Well,
when? And
so last year we were focused on the shallow edge, that eastern shallow edge. We spent most of our energy last year doing that instead of doing what we've done with Andrew and Beck and Lucy and Brennan. So we were focused on that shallow edge. So we didn't actually go out too much into the middle and survey the middle of the meadow. But last year at the end of the season, a couple of things. I went out with the rowing shells a couple of times. We brought the Hingham Botany people out for a tour, and we didn't happen to find any eelgrass, but I thought, maybe we missed we weren't doing a serious survey. So.
yeah.
But then every time we've been out so far this year, we've seen nothing.
Well, let's check it out. When we fly the drone over in real time,
Yeah.
we can be looking at the
Yeah.
screen and seeing what's there and what's not.
Wherever you want to get think about restoring eelgrass, should that be part of the plan? In front of looking over the side, telling me if I'm getting into either water that's too shallow for the propeller, or if we see our beloved plants. Okay, and then Beck, can you talk to Jill about flying the drone from the deck here?
Oh, yeah. We have everyone clear off.
Alright, we've got time because we're ready for particular questions, or do you want me to just describe the project to you?
Let's describe it, I guess.
Yeah, so I'm Jill Carr. I'm from the Mass Bays National Estuary Partnership. And you know Julie Simpson, she's one of our partners on the project from MITC Grant. And our project is looking at 4 different remote sensing methods of mapping eelgrass. So remote sensing meaning mapping it without putting your own eyeballs on it. Rolling.
We'll pull the boat.
They want to film during the tide, so we gotta get there.
Well, we made him probably pull the boat. That might be fast.
Yeah, go ahead.
Look at those two sitting up there. All privileged.
Turn that off. Turn that off.
Ow! That was loud. Don't hit me.
Charlie, I'm not in shot. What are you talking about, Uber?
Get behind everything else. Action.
Okay, ready? Wait. Do you want me to walk in?
Hello, my name is Finyamini. I'm going into sophomore year, and I'm expedition team leader for the eelgrass project.
What has been the most challenging thing about CSCR work this summer?
Just trying to find eelgrass beds. Definitely has been the most challenging thing so far.
So I just say, I'm Charlie Winery, I'm a sophomore, and I do expeditions and design.
Yes. Also, the question is, what is your name? Can you spell it out?
CHARLEEPUT. Hi, my name is Charlie Winery. I am a sophomore, and I do expeditions and design for CSCR.
Do you think you can apply what you learned in CSCR to life outside of the program?
I'd say that CSCR has taught me to be a better team member and help out with more projects.
The way we kind of collect data and the way we organize ourselves helps kind of mold you as a team leader. So you learn directional skills, you learn prioritization of tasks. It's just it's helpful for just anything that could happen later on in life with jobs and things like that.
I think helping design things to make collecting and studying eelgrass has helped out a lot. At least that's what I think.
Sorry. You went back and say so. Alright, that's what these things are for. Are we rolling? Yes, we're rolling.
What is your name? Can you spell it out for us?
My name is Riley Seaborn, RILEYSEABORN.
How would you rate your experience at CSCR so far?
I would rate it about an 8 out of 10. I really enjoy the subject, and I think it's excellent working with these people and understanding and getting a better knowledge of people skills, because I think personally it's a thing I lack and that I would want to work on. However, I think that sometimes it is a lot of time to put in, and it's a big commitment. So that's why I would take off 2 points.
What has been the most challenging part of the summer so far?
Personally, I think the most challenging part is mainly finding the eelgrass. It's very unfortunate that we have lost so much eelgrass in the harbor. It is hard to see, and it is also really hard to carry out our experiments because of this.
Your name? I'm Layla Al-Rashid. I'm a rising junior at Cohasset High School, and I work with the Dune Grass project at CSCR.
Okay, and what are you doing down here today?
I'm just trying to test out what they're doing with their project and get to learn about it a little more. So do you know how long you're going to have to do this experiment for?
We predict that each trial will take about 5 weeks, and we're going to run 3 trials, so it could take quite a while. We may have to break it up into 2 segments, doing 2 this fall and 1 next spring or summer.
Yeah, so are you going to do multiple with the same amount of salinity?
Yeah.
And then change it based on then? So maybe you can make all these tanks just the same salinity and see if it affects it at all, right? Because you're going to need a control. Because what if you change it, but it's just due to randomness or other factors and not actually due to the amount of salinity?
Well, we're trying to make all the factors as controlled as possible.
Mm-hmm.
But we're going to have a control of eelgrass that doesn't have CRS wasting disease on it, Then we have one with 40 parts per thousand salinity, one with the average of 30 parts per thousand salinity, and one with 20 parts per thousand salinity. So we technically have two types of control, one with average salinity and one without seagrass wasting disease, that will go through varying salinities.
So, like, what part of your project is this? Like, is this an off branch or working towards some end goal?
This is basically the meat and potatoes of the project, doing this experiment.
Well, I just mean eelgrass in general, because I know you guys have been doing a lot with your project,
Yep.
but I haven't really seen, like, an overall end goal.
The end goal is to get all the data extrapolated from the 3 trials, compare them, and then write a paper with the definitive results of does salinity affect eelgrass, or does salinity affect how seagrass wasting disease affects eelgrass.
Okay.
With eelgrass beginning to disappear globally, many fear that this stress may trigger the re-emergence of a dangerous opportunistic pathogen. Aggressively presenting itself in 1930, the disease known as seagrass wasting disease rapidly moved throughout the Atlantic Ocean while killing over 90% of all eelgrass in this region, with some estimates rising as high as a 99% mortality rate of all Atlantic eelgrass. An outbreak this aggressive has not occurred since, and its cause is still speculated about and remains largely unknown. Ideas regarding the role of the weather, temperature, and salinity in causing this event are still discussed, but proven mostly inconclusive. Seagrass wasting disease spreads through contact, where it is known to be highly infectious, although it is also known to spread through the ambient environment with spores. Once infecting a plant, activity acts as a parasitic infection, breaking down crucial cells to the plant, leaving black lesions.
To ensure accurate experimental results, our tank setup had to control for all other factors that could influence the spread of seagrass wasting disease. Namely, we had to control the temperatures across all of our tanks, ensuring that they were kept near nominal conditions for the waters near Cohasset Harbor. Though this was a relatively straightforward goal, there did exist certain design restrictions which made the design and implementation of such a system slightly more complex. As seagrass wasting disease can spread from plant to plant, we had to ensure that each tank had an independent water supply to limit cross-infection. Thus, we settled on a design which used 4 separate cooling pumps and cooling lines. Each tank had its temperature monitored by a probe wired with an Arduino, which modulated a relay connected to one of these 4 pumps when under the temperature in any one of these tanks exceeded a defined maximum. The current temperature and pump status were then displayed to the end user through a series of 3 small displays, allowing for easy monitoring and debugging of the entire pump and electronic system.
What's a major challenge that you faced during this process?
There's been quite a couple, as we are far behind the deadline, well, a lot further than I'd like to be. But the biggest one is that this year, the eelgrass has majorly disappeared from the harbor, and we've only found one patch of a eelgrass bed that we can equate to last year. And that took us quite a while to find, which was unfortunate.
would want to see something really bad. And I actually want to show them.
Yeah, sure. So you see, that's like a nice salty water. Well, the thing is,
not very well mixed. That's what I'm doing right now.
No, mixing it won't, because it's like a solution on the point where you can't add any more salt.
So Charlie, what are you doing?
Designing something to keep the pumps from falling down, because apparently that's happening a lot.
Worse to work with.
Like,
But
things like that.
like this first would be a lot healthier, so we would have to remove everything.
So I could probably just make like 2 more wooden rods sticking out the sides, so top view look like this. Pumps cut up along there, so it can't really twist around.
There's still a goal of putting a
I think
tarp
that would work
underneath
super
all
well, and it doesn't require too much. I could just probably just get some PVC pipe, maybe just tape it. Yeah, okay, that works. It doesn't look like it works, but it actually is working very well.
So how do you remove it?
How do you remove it? You just take it out, but it just can't fall in very well, which is a good thing.
Can we make it like even, so it's like straight across?
I mean, I'd have to.
Yeah,
Give me
can
a
you do
saw.
that? That would make it a lot easier for me.
Yeah, but can we have a? Yes, we do. Give it a second. This is really old. Oh, come on.
It's gonna take a while to figure that out, and like a while to get everything together.
Exactly, so we could be growing eelgrass.
But then we're gonna have to, after, say if we miss the deadline, we're gonna have to throw all that eelgrass out. We're gonna have to waste a quarter of our artificial seawater, a quarter of all our sediment.
We're just gonna have 1 tank.
Oh, only 1 tank?
We can just do 1 tank.
That might be feasible then.
We're doing 1 tank as a test.
Oh, when you put something in, so I can mark it down, okay?
3.5 inches of sand.
Okay.
Okay. Level it out though. Level that out.
Yeah, that's what I'm doing.
We don't know. Max.
This is actually a little wet.
Yeah. Get the YSI ready.
All right.
Please.
Please. Get in there, That's fine.
Now we use this. Alright, this is the order of the tanks. Yellow, orange, blue, purple.
I hope you measured the amount of water you get. Whatever.
It's around 4 gallons. I want to be very careful. I'm going to do it kind of like this. Hit the side so I don't crazy disturb.
And this is going into tank A. This says that 20 parts per thousand is our target. Try 40 ml of instant ocean, packed down for 5 gallons distilled water.
Testing now, that's gonna be 40 ppm.
What works?
Keep it on there.
Which one works?
1 and 2. Wait. Which one is 1 and which one is 2?
Hold on. You just stand back and let us finish what we're doing here.
All right. Yeah. Go ahead.
So that relay is bad.
Pump number 3, the blue pump is broken.
Pump or relay?
Okay.
That would be the pump. It was a short circuit.
The pump short-circuited. Does this mean we need a new pump then? Well, Carl, are you working on something, or can we discuss this?
Now let's plug in. So let's get this one out of here. Pull this wire back.
Unfortunately, this project hasn't been going the way we expected, due to a multitude of issues such as the heat wave, the lack of eelgrass, and the slow pace we've been moving at due to my overconfidence in what we could accomplish. We have not much to show for our efforts this summer. We've had the tanks set up, but we've only had 1 successful tank with living eelgrass. The 4 experiments we currently have set up have died. This is due to the sediment, as well as some malfunctioning protein sequence which have caused mold growth. We also have had troubles inoculating the eelgrass with CSCR disease, as the petri dish experiment we tried to do earlier didn't work out in our favor, with none of the clean plants taking on the infection, which is contrasted by what happened with the earlier tank I had mentioned, where the petri dish experiment worked well. We're still trying to figure out how to continue our success.
What do you think is causing this to happen?
There's many theories, including algae, animals, changes in the ocean's climate, or my personal favorite, seagrass wasting disease, because it's what I'm studying, and I think it's plausible, as this is similar to the 1930s outbreak in Atlantic Ocean, so it's quite similar, and it could happen again, which would be a very interesting story.
Can you actually explain to me what the plan is for this afternoon at this point? Because we have gorgeous weather, we have low tide at 2.
We're gonna have
possibilities at 2:30.
2 teams, 1 expedition team, 1 field team. The field team's gonna be working throughout until 5 to get the tanks ready, and the expedition team's gonna be harvesting eelgrass for 1 the tank study, 2 petri dish study, and I'd also just like a couple of various strands for other experiments.
So how many plants do we need?
For the tank study 12, it would need a lot of plant matter, both CF wasting disease and clean, for petri dish and other studies.
This is our final chances here to harvest eelgrass, or else we're gonna have to wait till next summer.
What else are we going to need? We're going to need the anchor ready. And they're going to pick up speed when we get past the 4th dolphin, 3rd dolphin.
We now have the Quadrat and Logitech with GoPros all ready, full battery.
We have a lot of mysteries this summer that people are curious about. Why has the eelgrass disappeared from everywhere except here? So this is a good time to look around and speculate about that sort of thing.
Everything we've done so far has led to this.
Can't say you know that. This is a culmination.
You can't really see through the water.
Culmination point.
So I'm trying to anchor so that when I drop the anchor, the boat will float into the place over the eelgrass.
The eelgrass is very white here.
Oh, whoa! Yeah.
Very unnaturally colored.
It's really pale. I don't think it's supposed to look like that.
Don't harvest the white eelgrass.
Right, it's the 7th of October. We're at Nick's Cove. We're about to do our last eelgrass expedition before it gets too cold. So it's very important that we harvest 20 plants, I think. Yeah.
And not more,
Yeah.
right? And you want to tell them why we're not harvesting more than 20?
We don't want to hurt the already like dwindling eelgrass population. So we're just taking what we need, no more.
If you start feeling funny in any kind of way, just come on back to the nice friendly boat and we'll get your worm and head home. Okay, so no eelgrass is worth anybody getting hypothermia.
Exiting the boat. Right?
I'm getting there. At least there's not like
up the current.
really bad. There's not bad wind, but that's not usually a problem. That's just for like your hands. Because wetsuit's good at blocking wind, but oh my god.
Okay, I can feel my hands going numb.
Yeah.
Okay, everything right here is dead. Everything's dead.
Okay. Down we go.
Alright, without ribosome, I got a dead sample.
This is not good. This is probably what has caused the whole eelgrass disappearance, and now it's happening to the one remaining patch of it. Okay, I'm gonna go down and should I grab It's like a headache every time I come up.
did you start recording?
Yes, I've been recording this entire time.
And action.
Hi, I'm Max Fernald, a student at CSCR, and I love any type of aquatic biology, so that's why I love being here.
That's not a very good introduction.
Well, what did I say? I'm not good at introductions.
It's the first time everybody's here seeing it. You know what? You know what I'm gonna do?
Just do like one of those like captions in the bottom corner where it says Max Fernald, CSCR student. That's what you do, right?
Yeah, go over there.
So we have plants and tanks after a month of preparation. Problem is, over this past weekend, we had high heat, and that tanked the freezer. The freezer went offline. It had lukewarm water, so we had to defrost the freezer by turning it off. We killed the pump system, and that led to temperatures rising in all the tanks above 75 degrees Fahrenheit, the sublethality rate of eelgrass. We also had the pumps on shortly in tanks C and D, which led to them rising above 80 degrees Fahrenheit, much above the lethal temperature for eelgrass. Now, all the tanks are showing signs of cellular necrosis within the eelgrass, especially C and D, which look sickly and are dead. We don't know if we should continue this experiment or scrap it and start a new one. It's an important decision because we're running out of time fast.
What are the tanks at now, temperature-wise?
Around 74 Fahrenheit.
22.1 to 23.3 degrees Celsius.
Probably 25% chance that A and B die in the next month. Tank C and D, 50 to 75% chance they die within the next month.
Well, can we afford to lose like a week, or can we afford to lose 15 days plus a week?
The problem is, if we sack these plants, that means we kill the chance of a third experiment, and we have 2 experiments left that we can do that are risky. We could alternatively continue this experiment, get as best data we can, and invest in research and development so that we have 2 more experiments, with one very risky being in October. However, at that point we would have lower temperatures and a higher chance of survival from the eelgrass.
Well, so maybe, what about, let's go back to the idea of, can we get 2 things going at once? So say we go out to pluck seagrass wasted disease from the field. What if at the same time that we're diving, what if we also take another 12 plants? And can we get those 12 plants into a tank situation or buckets or whatever that would give them their 15 ppt time, and then could we just add them to the tanks? But if we could get out early and get plants and keep them in a life support system equally, then they would be here. We wouldn't have to be at the whim of the low tides and the availability of divers. That's the advantage of that.
I think it's actually a good idea. That would make a lot more sense.
Calendar, is that the next step?
Yeah. For what we're doing today, 2 things. We have to clean the pumps and assemble them back together, and we're going to redo the entire hose system. That's pretty much it. Christian's probably going to be doing a lot of hose assembling, or the pump assembling, my bad. And everyone else, we're going to need to cut the hoses and use these connectors to fit them back together.
Well, we need someone to look at this to see if it looks too bent, because I don't trust that really.
Is that not how it's supposed to be?
Yeah, but this thing looks very bent.
So I just made a diffuser for the hoses, and they're directed upwards, so it doesn't. Well, yeah, we also too. We have another one, and it's just made of like PVC and duct tape, and it points up, so it doesn't like kick up sand and like affect too much. And so this is the last one to put in. The other ones are all good, and I think we're gonna test them now.
You want me to run them?
Yeah.
Alright, running them. You good?
Not thoroughly, but once through, yes. There we go. That is not going down anytime soon.
Next, I'm gonna do it. Alright, well, don't damage the freezer. That should be good enough.
Yeah, there's a second one though. Behind it, that's way
Holy
further
shit.
in.
Oh wait, there's a good transition here. Look at the car.
Also, should probably be using a flathead, not a round.
I can find the flathead. Good eye. Oh wait. I'll mix it for your clip. Do we have a mixing stick?
What's going on right now?
We are getting the tanks ready.
For what?
Next harvest, tomorrow.
Why?
Why do you think, Owen?
It's for the movie. I'm not asking to annoy you.
No, you two are.
You have to explain it.
No, I don't. I'm busy. Those are the output.
Yeah.
I might run it through to put the input in and the output out.
I thought you meant that was the part that was rubbing it against the eelgrass. Oh, and you're not putting this in the movie.
Maybe I will.
If you do, I'm suing it for defamation.
Defamation. Actually, he's filming, so it's legally his footage. You can use it in whatever way.
Okay. So basically, back up. So basically, what we're doing here is Charlie, this guy, he doesn't know what dream school he wants to get into, so I'm trying to motivate him a little to come up with a list of schools that he might like to apply to, because like even Eamon over there, you know, Eamon.
Yeah, even stupid Eamon, right?
Yeah, even stupid Eamon knows what school he wants to go to. So like, why can't Charlie? We're also filling these buckets of with bleach and water to clean them out, so we can put eelgrass back in them when I harvest it tomorrow. Why? Why are you harvesting? The experiment must go on.
Half this stuff, it's 91%. You know how fast this stuff vaporizes?
Yeah, a couple minutes.
Yes, a couple minutes.
Oh, not like...
It goes fast.
What does neutralizing the tanks mean?
I think I've got all this muscle, man.
What?
I think I've got all this muscle.
Wow.
Ready?
You want me to actually explain?
Good. Look at this.
Yeah.
It means that we're getting in this case, a weak base to get rid of the hydroxide ions left behind the bleach we put in earlier. Basically, get a neutral pH so that the eelgrass grows fine, so we don't have problems with it being too acidic, too basic.
A bucket full of water?
So we're filling the tanks with water so that the sun will dechlorinate the tank water, and then we'll bucket it into the tank. Oh wow, that's a rainbow. Oh, and you should film it.
And make it black and white.
All right.
Nope.
Well, no, because you can't see his nose anymore.
Yeah, it's a little bit better.
It's like, it's more...
You do look like less of an idiot.
Huh? How do you feel? Say something. How do you feel about the expedition?
I think it'll hopefully go well.
How do you feel about the expedition? No? Theo, how do you feel about the expedition?
What? Why are you zooming in on me? Why are you filming?
Because you just said, all right, and then you're probably going to give a speech.
Yeah, come on. Give us a speech. You know what, guys? Susan was right. We need to work together as a team. Hands in the middle.
CSCR on 3.
1, 2, 3. CSCR! Oh, yeah.
I believe we're going after 24 plants for the tank.
Is there any specifications for like deciding a plant?
We're gonna just go for the ones with the least amount of wasting disease, and then the plants with wasting disease on it will turn into like kind of a slushy, and then we'll also attach it to the plants to infect the ones that we've planted in our tanks with wasting disease.
See? It's very advanced.
I think we're planning.
So we gotta get 24 fronds
And then
I think we're only planting like 12.
Okay. So are the
Yeah,
other
planting
12 for the wasting disease sample?
Yeah, I guess. 24 is the highest.
The upper limit?
Yeah.
And I guess
the 20 is fine.
So how exactly do we extract the fronds from the ground? Because I know that we have scissors. Do we like cut the leaf off? Or
so you
grab it by the roots? Okay. And then once we have the plant, once I have the plant, what do I do with it?
You can swim over to the boat, hand it to someone, and then we'll bag it, put it in that bucket over there.
Okay. Like a plant?
Sounds like a plant.
Yeah, so there's things like, you know how many times you dinged your
Do you want me to cleat it or just let the
cleat it.
rope? Okay.
Alright, so I'm gonna snub, you know, a little silly.
Alright.
A little brisk.
Alright. Am I going with you guys or am I going with
Yet this plant will continue to disappear, and the clock is ticking.
Alright, wait, now. What I want is the longest walking off scene.
Wait, Matt.
Alright, cut!
That you to start?
Giving a compliment.
You know, when you're in high school, there's not that many ways you can totally differentiate yourself from other students. But as you apply to college, as you go looking for jobs, as you go looking for employers, you do want to differentiate yourself and know what you're good at and be able to talk about that. And a nice easy way to be able to say it is, well, I was on this team and my teammates noticed that I was the person who blah blah blah. So yeah.
He has nothing good to say.
I can start if you want.
Okay.
I think Max deserves the most compliments because, well, you've led this whole team, kept us going for 2 years, like every month for all 2 years, and you've just put in so many hours, so I think you deserve, I don't know, some recognition.
At the very least, some round of applause, but yes, some recognition. Yeah.
Alright, I can go next. Both Eamon and Bridget, although you didn't really have like a specialized role per se, you two were probably two of the most consistent people at CSCR, and like when we needed to get stuff done, you were there, and that was very helpful. We couldn't have like gone through the project without that.
Christian, I mean, when Issa left, I mean, we didn't know how to do this, so.
I still don't.
You got it done. It was very helpful.
Theo, I mean, we're all juniors in high school here, or yeah, all of us. And you're still in middle school, but you showed up and you managed to keep up with all the work, even if it was complicated.
And Theo, I also just want to add that there were times where everybody's forcing around and you were like, why don't we just do this? And I was like, oh my God, somebody's focused.
To continue that, Susan, without you, I would be trying to manage a project that was like, what, 12 rounds with 6 tanks or something? That was my original idea. Thank God you were there to talk me out of that.
Yo, you dealt with me for 3 months. That's good enough.
Bridget, I totally appreciate you dealing, like I got complimented, dealing with a bunch of teenage boys. Holy mackerel. You rock.
Finn, even though I scheduled everything, you were the person who sat down and got people to actually come here through messaging them. So thank you for that. Without you, it'd be like me and you and no one else.
And also showing up never in a glum mood.
Thank you for being head engineer, Charlie Winnery.
And the other thing about Charlie is he's got 0 body fat on him and he gets cold really fast and he would still go in the water with you.
Yeah.
Max, you've already basically received this, but you're pretty much the reason this thing kept on track throughout the whole, for me, like year I've been involved in this. You've kept everyone like on track with deadlines, made sure you got what you needed to do, helped out a ton with reconstructing the tanks in the summer last year as well. Dude, I don't think it's that hard to set up.
Yeah. Want to go pose there?
They are. Try to get the scanning software working.
What are we doing today, Max? Ready? Wait, hold on. Are we ready? What are we doing today?
We're extracting plants from our last round of the experiment.
Okay. What do you expect the data will show?
I don't know. I haven't looked at the data of these rounds terribly much, so I have no idea.
So what are the possibilities that the data might show?
Well, the 3 kind of analogs to it. The 3 kind of like possibilities are either there's a correlation between cirrus wasting disease and salinity. There's a negative correlation between cirrus wasting disease and salinity. There was no correlation that we can draw. So either positive, negative, or not applicable.
Okay.
Today's the last cut.
They just do normal.
It's our favorite time of the month, guys. You get to extract the plants. So fun.
Right.
Yeah. Woo.
I have a feeling this is all making Final Cut.
This is unedited sequence. Me talking directly to the camera. Going across stare.
This is what you get on a CD, you know?
Okay.
Does the hood stick show like on my board?
Yeah.
This is one of our most important graphs, which compares the percent change in serious wasting disease overall in the plant against the 3 different salinity treatments. So we have one grouping here of 20 parts per thousand salinity. This is 30 parts per thousand salinity, and this is 40 parts per thousand salinity. Each of these green dots represents one single plant that we analyzed, and these are the percent changes overall in serious wasting disease coverage as a percentage point. So as you can see, we had pretty much the most change, or the most varied change, in 40 parts per thousand, which also overall came to be higher than 30 parts per thousand. We had fairly low change in 20 parts per thousand, with even 1 point losing serious wasting disease coverage. This could either be an error or a demonstration that eelgrass is better at 20 parts per thousand. Overall, we had a very slight slope, which is positive, and came to an R-squared value of 0.014. This explains that 1.4% of the change in serious wasting disease coverage is explained by the salinity treatment, which is fairly similar to another study which had a R-squared value of 0.017 or 1.7%. There's a 40% chance that salinity is responsible for a seagrass wasting disease infection change, which seems low. However, with more trials and with a larger sample size, we can definitely shrink that down with more data points.
Satisfaction? Are you happy? Are you proud?
Yep, I guess. I'd be satisfied with any results pretty much, as long as they're, not insanely skewed.
Okay, that's a really valid and important statement, I think, and it has to do with who you are and what.
Any good scientist shouldn't, hope for a specific data set, otherwise they're biased. So, the whole point of, this isn't the most strong correlation. However, it is a correlation, and we're happy with that.
I would say the data points to the fact that there is a very low, very small but positive correlation between seagrass wasting disease and salinity.
No sign of that middle rock anywhere?
Good. Actually, I would go maybe this way a little.
The 9.1.
But I think the GoPro will be our friend.
I think the tide's a little too high right now to really see the eelgrass with the equipment we currently have, but hopefully we'll find something.
We are at Nick's Cove. It is May 31st, 2024. We are throwing in the quadrat to see what the eelgrass presence is looking like. What's the tide? It's a high tide, almost. An hour and a half till high tide. 9.1. When
was the last time we were here?
Last time we were here was
Last time you were here.
October.
Cool. And it's on. Yeah, it's not sinking very fast, is it? I think we might need to weight it a bit more.
Could you just cut holes in the PVC?
My coolest story is last year, it was the end of the year, and we were looking for eelgrass in a place we haven't seen it previous because it was a very shallow area. And suddenly we got past this one patch of dark water, and the conditions were perfect. And we found these plants in this perfect ecosystem with a little piece of all of the harbor, with every animal I've ever seen in the harbor all in this one little place. I think we called it the Garden of Eden.
What's your favorite part of CSCR?